Good. So thanks for joining us today, and good morning to everyone. This is the Open Science with the NASA-ESA-JAXA EO dashboard side event. And just to make sure that all of you will be able to follow the hands-on part that is part of this side event, I would just like to ask you to go to this website. So it's BiDS'23.hub.eox.at. Hope you can see it, or I can try to make this bigger. No. Oop. Put it on a. Okay, I'm just gonna BiDS 2023 hub AOX 80. Okay, and this way, when you complete your registration, you'll be able to log in to the platform and then follow along all the exercises. So this is the agenda that we shared with you. Is it working? It's not working. Nope. Okay, so full screen doesn't work. Uh-huh. Okay. Just gonna leave it like this. Okay, so this is the agenda. For now, our colleague Kaori from JAXA hasn't made it yet to the site, so we're gonna just move her part to the end. Basically, we will have a short introduction to the project, and we saw from the poll that we shared with you all that not many of you know about the EO dashboard and the Veda platform. So this is good because you'll learn something new. But just to get an idea of who's in the room, we got a few responses here, and we see that there's quite a good knowledge of Python, notebooks, some knowledge of Eurodata Cube. Many of you are familiar with Stack and QGIS. JavaScript as well, so I think it should be working out fine. Good, so back to the agenda. Just saying again, there's a small change. So the part of JAXA is gonna be probably left at the end when Kaori makes it with us. So I'm just gonna continue with introducing a bit the project. We're quite a large team here on site. So we have, I'm Ankam from ESA. We have Olaf from Development Seed representing the NASA work. We have Lubo from EOX, who's gonna guide you through some of the technology behind this project. And we have Diego in the back from REA, and he's going to, let's say, lead a few of the notebooks that we're gonna show. So what is this EO dashboard? I'm gonna try to put this in full screen again. Let's see if it works. Doesn't want to. Maybe like this. No. Or yes. Okay. Okay, so this is a project that we started in 2020. It's a collaboration that we have with between ESA, NASA, and JAXA. And in 2020, we started this cooperation with the objective to see if we can use the tri-agency satellite data and see if we can identify some impacts on the society from space, so using our tri-agency data sets. And we launched the dashboard, which is the one that you will be working with today. And because we noticed that there are many more things that we could do together, we decided to extend this collaboration and go beyond just COVID-19. And now we're addressing several environmental topics, and you'll see which these are. In 2022, we decided again to extend this collaboration, move more towards open science and engage more with the open source community, and try to develop a platform that would be, let's say, more engaging to and bringing on contributions from the wider community. So this is a bit the timeline that I've presented. We were participating in several competitions. So the EO dashboard is part of the resources that are contributing to the NASA space apps, for example. We also organized a hackathon back in 2021, which was a global hackathon, quite good participation. We had over 4,000 people participating in that and about 500 teams if I remember well, that use the dashboard and the platforms that you're going to work with today. And in 2023, we were fortunate to receive this award, the 3 agencies, for this extended collaboration. So we hope to move forward with this for some time in the future. So 4 things that we are looking to provide with this dashboard or with this project is, first of all, we work based on open principles. So we foster open science. This means that the data sets that we provide are open, the insights, the findings are provided openly, and they're all collaboratively developed by the 3 agencies. We leverage a lot of the infrastructure developments that we do at each of the agencies. So we provide data visualization capabilities, computational resources, again, by the 3 agencies for scientists or just EO enthusiasts to work with the EO data. We try to foster innovation and partnerships, and I'll guide you a bit on how we plan to do this in 2024, and engage more with the community through events such as this one, but also contributing to other trainings, educations, and education events and things like that. So there's quite a bit of data in the dashboard, but actually the data doesn't sit on the dashboard. It's actually sitting on the platforms that are serving this data. So EuroDataCube is one of the sources, several of the data sets from the European Commission, NASA data sits on their own infrastructure, JAXA data sits on their own infrastructure. So we just pull in data sets that are relevant to illustrate a specific phenomenon or to illustrate a specific change that we're looking at, environmental change typically. So we cover 7 domains: atmospheric science, biomass and land, oceans and just inland water, economy, agriculture, and the cryosphere. And there's quite a few missions from all the 3 agencies that are contributing with data to these indicators and to these domains. And quite a few areas of interest that we're looking at. And here you can see just a bit the numbers. So some of the data sets are local. We have many global data sets, which are the ones listed here. So what can you do with this dashboard? And I'm going to move to the demo in 1 minute. First of all, there's the data discovery. So you can discover the various data sets and the various indicators that are presented here. You can either do that from by searching on the exploration interface, filtering by the themes, filtering by some keywords, or you can discover these data sets within the stories. So there is one strong aspect of storytelling that is related to the dashboard, in the sense that each of the data sets, each of the indicators that we present, they try to describe something. So we observe a specific change, and we use data from the 3 agencies to describe that change. So this description is actually encapsulated in a story, in an interactive story that is composed of some, let's say, copy or some text that is presenting that what is happening there, what we're observing, the data set that is associated with that, which you can explore on a map and you can interact with. And now we're moving towards also providing an associated Jupyter notebook where you can actually interact with that data or even reproduce the science that is there. So there's the data discovery aspect on the one hand. We're moving towards a more enhanced, let's say, data discovery. Now we're working to provide all the data sets as stack. So working to have a stack catalog, and this will enable us to be able to, let's say, discover data more easily, so filter by more terms, not just by a keyword, but also by the Earth observation mission that is contributing there, the theme, the location, and so forth. This will also help us to have, let's say, a more descriptive metadata displayed on the dashboard together with the data sets, where you would be able to understand a bit more what is the, let's say, method that was used to produce that data set, how you can access that method, what is the associated paper, if there's a journal paper there, who's produced it, and many other metadata associated to that data set. The access to computation, currently, as I was saying, the dashboard is, let's say, starting from these stories, and within some of the stories, we started already to incorporate these notebooks that you can then execute on the platforms that are hosting them. But we're moving towards something a bit more advanced, and that is, once we have this enhanced metadata panel, you'd be able to go to the platform that actually hosts that workflow and that actually hosts that data set and work there directly. So not just visualize that notebook in the story, but also get access to the underlying platform. The aspect of storytelling, how it currently works is that we have scientists from ESA, NASA, and JAXA that are doing research, and they work together to produce a story, let's say. So they identify a topic that is of interest. For example, we recently published a number of stories on inland water, so shrinking water bodies due to various factors, anthropogenic but also climate change. And the scientists identify which are the data sets that would be useful to illustrate that change, right? And they come up with a storyline, let's say. The storytelling basically comes from us. What we want to move towards is where users can do their own storytelling. So using the dashboard resources, the data sets, the storytelling building capabilities, they would be able to be the ones that are putting content there. So how we plan to do this in 2024 is to have, let's say, dedicated workshops hosted by ESA or hosted by NASA or hosted by JAXA, where a group of scientists, young scientists, typically would sit together for a week, brainstorm around the topic, use the platform services and the data sets to identify some information or to extract some information from the various tri-agency data sets. And then those findings would be described and encapsulated in a story that is then published on the dashboard, so that the stories would be, let's say, a way for young scientists to promote their work and thus gaining visibility on a platform that is, let's say, vouched on by the three agencies. Just a bit about who are our users. So we have about 200,000 users so far, and several universities and companies are using the platform to provide training in their classroom or as a class assignment, or just to illustrate data visualization and data science with Earth observation. We're present at various events. This is one of them, but we have some others upcoming. So if you are attending COP or IGARS next year, we'll be there as well. Good. So I think I can move to the demo. This is just to recap a bit what we are doing in the next period. So we're moving towards this community-contributed storytelling. Typically, we hope that we'll be able to organize several of these workshops with the community, with dedicated groups to produce these stories, and connect further with the open source community and the open science community in general. So, demo time. Let's see if this works. Yes. Okay, so the dashboard is accessible at eodashboard.org. This is the home page. Basically, what you find on the home page is the various themes that we're addressing. So we have atmosphere, agriculture, biomass, oceans, cryosphere, COVID-19, and economy. And each of these themes has a number of stories that were developed for it. And on the homepage you see a random selection of these stories. But if you go on each of the various themes, then you can find the dedicated stories there. Some of the latest ones that we've published, as I was saying, are on inland water. And typically, how we produce these stories is that each of the agencies is working on content that is, let's say, specific for their own region. So Europeans are looking more towards what's happening in Europe. The Americans are looking more towards use cases in the US or across the ocean. And the Japanese agency is looking towards what's happening typically in Southeast Asia and the Pacific. So just to illustrate a bit how the stories work. So basically, each of the stories is, well, this is an intro story that kind of guides you towards the following stories. So we link to the stories from this one. But typically you would have, so this text that describes the problem. Here we look at impacts of climate on inland water. What are the typical parameters that we monitor, like surface water temperature, water level, water surface, water quality, and so forth. And then you have access to, you link to the specific story that actually illustrates that. So for example, this one is looking at how changes in temperature, precipitation patterns, and extremes are impacting surface water hydrology. And we illustrate this in several locations. Okay, so this is an example on the effects of climate change on the Colorado River, which is in the west coast in the US, an important water source for several applications, irrigation, energy, and so forth. And we have this like map where you can explore time series of Sentinel-2, in this case imagery, and understand a bit better what's happening there. Apart from, so you can just browse through pages, and each of the pages looking at a different location. This one is Tonle Sap in Cambodia, illustrated by JAXA data. So this is ALOS-2 data on the Tonle Sap lake, and again, you can just explore this data set. Some of the stories, as I was saying, have these embedded notebooks. This one is a notebook that you can run on the Eurodata Cube, so you would be able to discover this on the Eurodata Cube, and just try to guide you on how to use the same data that was used in the story to produce a similar indicator. In this case, we use Sentinel-2 to delineate the water bodies and see if Sentinel-2 or Sentinel-1, which of the data sets is better to use for this application. The stories are, let's say, powered by these data sets. So the number one thing to do in order to get a story here is to have the data sets integrated in the dashboard. So this means that the data set has to be available on this exploration interface. So this is, let's say, the more advanced interface where you can go and explore all the data sets. So here you have the possibility to search for the, let's say, local data sets, and the global ones are typically listed with these tiles on the lower side of the dashboard. So what you can do with these data sets, typically you can explore the data set on a map. You can browse through the time series. And if you're interested in doing a simple analytic, you can just use this custom area drawing and generate a time series that, in this case, queries the NASA API, because this is data coming from NASA, so the NASA OMI. And you can see in this particular region, somewhere close to the Persian Gulf, how the, in this case, yearly variation of nitrogen dioxide looks like over the years. So in this case, you see it's almost constant, but has a slight increase. Yeah. You can also browse through the various dates. So clicking on the chart would take you to the respective date. Oops, something happened here. Small bug. Let's try. Hi, everybody. Okay, so we're complete now. Okay, let me try that again. Let's see if maybe it's just for that specific data set. Okay, I will try with the carbon monoxide. Okay, so this is carbon monoxide product from Sentinel-5P Tropomi. I'm going to try and do the same thing, but I'll just select a random area. So this is data that is provided by ESA, meaning that in this case we're we're using the Sentinel, the Synergize or Sentinel Hub statistical API, and well, you have a few gaps in the data, as you can see. It's not full coverage, so but you can understand a bit what is the periodical behavior of this data set, of this observation. Okay, so here it is, the feature that I wanted to show. So if you click on a specific date on the chart, then this synchronizes with the map, and you can do the same from the other way around. And finally, what I wanted to show is how you can create your own custom dashboard and basically package a story or prepare for developing your own story. So you have this add to custom dashboard feature where you can just take this view of the chart that you have here and add it to a custom view. And this creates an element on this custom dashboard. You can keep adding elements to this custom dashboard if you haven't finished yet. So I'm just going to go back to this data set. And the area of interest still remains there, so I can just add also the map if I want to support my story. This would create a second element here. And the nice thing is that it remembers where I was looking at, so it's centered on the same area as before. And if I want to add, let's say, another data set over the same area, let's say I'm interested in the crops. Okay, I'm gonna add that as well. So this is just random selection, but you get the idea. So apart from these maps that are providing the same information and the same level of interactivity as the ones in the main dashboard, I can support my image with additional text. So let's say that I'm gonna say here something like page number 3 or 2 and some text here. And I can just use Markdown to add some supporting text to my story. So this is a custom dashboard that I can save. When I save it, say BiDS, I have to give it a name, indicate what I'm interested in, and provide an email where I will receive the links. Okay, so now I get a viewing link and an editing link. The viewing link I can share with anybody, and they will be able to see the exact same view as I have, but they won't be able to edit it. While the editing link takes you to this same view, and your coworker can edit, let's say, the dashboard, the custom dashboard. So to move from this to a story that is published on EO dashboard, so this is the thing that you need to prepare. So the data has to be integrated. You need to be able to have the corresponding text, so describing the respective story, and then once it's published, it's going to look something like this. So it transforms it from a custom dashboard into a story. We can have like a cover image here, like you've seen before, and then this would be the published story, looking something like this. Okay, so this is what I wanted to show. We're going to now guide you a bit through the technologies that are behind this project, the platforms, and you'll be able to work with some of the data and run some of the notebooks that we've shown here. Okay, so thank you. Going just a bit back to the agenda. So now I think, Olaf, you'll be first?
Okay, yeah.
Yeah? Thank you.
Hi, everybody. My name is Olaf. I work for a company called Development Seed, and I'm here to talk a little bit about VEDA, which is a project from NASA that we're working on, and I'll talk a little bit about how VEDA is supporting EO Dashboard. Let me see, here it is. Oh, no. Wait a second. Somebody. How do I get? Yeah, I'll just close. Wait, the problem is I don't see what I on my screen. What I see there. Wait, maybe this button? No. Sorry? Yeah, I just don't know how I get. Oh, there it is. There it is. That one. Okay. And now, other slideshow. Okay. Good. So maybe quick show of hands. I think who here has heard of cloud native analysis ready data? Great. Stack, I already saw in the beginning, right? I think most people, great. Okay, cool. So I think these are two core concepts, right? So when Anka says we're going to talk a little bit about sort of the underlying technology, I think these are sort of core concepts that enable EO Dashboard. I will not talk about this. I will just do a very quick plug, which is we recently, NASA Impact, which is the organization that works on the VEDA project. So together with Impact, we published this cloud native guide. I would recommend you to check it out. This is an initiative together with the Radiant Earth Foundation, so go and check it out. It's open. I'm sure there's a lot of people here that could contribute to it. So that's a quick plug. I also won't go into Stack, but also a quick plug. Tomorrow we do have a Birth of a Feather session organized together with EOX and a bunch of other people. So join us tomorrow at 5:30 if you are interested in or working with Stack and want to meet everybody else at the conference that's organized or that's interested in Stack. Cool. And then I think one of the points I think I wanted to make is that both analysis ready cloud optimized or cloud native and Stack get you a long way to fair data. So find data that's findable, accessible, interoperable, and reusable. The VEDA project, and I'll go over this very quickly. Anko already said that the collaboration between the agencies started around COVID. After the COVID dashboard and EO dashboard, NASA continued with sort of the VEDA project. VEDA stands for Visualization, Exploration, and Data Analysis, and this is really the showcase of NASA of sort of what cloud native and Stack can do. And VEDA is also partly powering, or is the technology that powers the NASA data sets that are going into EO Dashboard. So right now in VEDA, we have 120 something data products. Here are some links. There's a dashboard as well that you can check out. I won't go over the dashboard very much today, but you can check it out yourself. There's documentation, and here are some of the organizations that are behind VEDA. But I'll go over this super quick. This is an example of the VEDA dashboard. And I think very similar, some of the very similar functionality that Anke was also showing. But what I wanted to show was sort of what Veda under the hood, and especially the part that is also, where the data sets are that are partly powering EO dashboard. And we're in Veda we're using a technology called EO API, and this is a collection of stack-friendly technologies where you put your data on S3, then we're using PG Stack to catalog the data. We have a Stack-Fest API, which is also an open source project, to make it discoverable. Then on top of the API, we have T-tiler, which is a dynamic tiler, which is built on top of PG Stack. Oh, and then we have a features API. Later on, so I think Luba will go a little bit more into some of the stack in a little bit, and then later on in the notebooks, we'll actually get some hands-on experience in using the data from this stack. Anyway, this all comes together. So this is so Veda under the hood uses EO API, all these stack-friendly technologies. You can check it out on eoapi.dev. And yeah, I think, the one point I think is when you have data in, when you publish it, when your data is fair, right? What we're trying to do with sort of the Veda data side of things, you can power all these different use cases. The same data source powers the Veda dashboard. We recently launched the Greenhouse Gas Center, but it can also power EO dashboard, and that's a really compelling thing, especially for scientists, for example, on the NASA side. They publish their data product, and by publishing their data product in a single way and publishing in fair ways, you can enable all these different use cases in dashboards, and yeah. And that's everything I had on the Veda side. I know Luba was going a little bit more into. Luba, is it you now or is it Corey? Okay. Cool. And then later I'll be back to take you through a notebook to actually get some hands-on experience with this stack.
Hello, my name is Lubomir Dolezal. I work for a company called EOX, and we are one of the contributors to the whole EO dashboard, mainly as developers and operators of the front end that is behind it, but currently looking also at the integration of the data. And what I will now hold is an interactive session that you can follow along, or you can decide not to. That's completely fine by me, but there is the option to do so. As Anka has already introduced, there is a workspace environment prepared for you that is under the URL BiDS'23.hub.aox.at. And you can register there if you didn't yet do, or you came, for example, late. After clicking Access Your Workspace, because I already am registered, there is a Jupyter Lab interface prepared for you, where all today's interactive sessions will be held on, both mine for the stack catalog browsing and editing, and for the follow-up notebooks that Diego and Olaf will guide you through. So when you want to run the same notebook, you can go on the Jupyter Lab-based interface, which will lead you to a home page of our Jupyter Lab. And for you, there has been a prepared set of curated notebooks. So under this catalog, in the bottom of the page, you will see all the notebooks that will be presented today. And one of them is the EODash catalog demo. So when you click on it, you can see how it is prepared without in the basic form, and you can click on execute, which will copy the notebook to your personal workspace that you have on the platform, and you will be able to run it and make any changes to it. And these changes will stay just for your user in your user workspace and will not get propagated to the main that you are all copying from. I already did that. I have got the notebook copied to my workspace, and now I'm looking at it at here. No, I have not, so I will open it here in the file browser on the left. And before actually venturing on our journey, I will, even though some of you have already heard what Stack is or are already maybe using it, we still will give a little bit of introduction of the concepts, but on the tool called Stack Browser. It is a web client that lets you browse through both Stack catalogs and Stack APIs. These are two concepts. I will already show the first link, which is a deployed Stack browser accessing our EO dashboard catalog that is still in the making. So this is not the final version with all the metadata filled. This is something we are still working on. And also notice this the demonstration that was held by Anka about how the EO dashboard looks like now is not, that version is not yet using this Stack catalog. But most of the data sets have already been migrated to the Stack, and the Stack has got three concepts of entities. First is a catalog, and catalog is a set of collections that you access, and each collection for us is the indicator on the dashboard. And for each collection, you have a set of items. Item you can think of as a product in the Earth observation terms. Any Sentinel-2 scene would be a single product in this hierarchy. We have got, for example, the nitrogen dioxide entity here, which will be a collection. And I'm now looking just at the trilateral catalog, and currently we have three catalogs in our system: the race dashboard one, the trilateral dashboard, and the GTIF dashboard. So going on the default page of the catalog, I can see a short description of the collection and also some kind of image that I have defined that will be there representing the whole collection. For us, it's the legend of the visualization that is then used in the dashboard. Because there are multiple sources of data, as was already mentioned, we need to somehow make it easily accessible, discoverable, and we need a unified access. And for us, this is the Stack catalog, which has a unified form that you will interact with in a few moments yourselves. So what I'm now showing is the description page of the collection and a set of items. One thing to notice is we are not using a Stack API that would allow you queries based on the metadata. We are using a static catalog, which means that if you access this data, for example, via the Stack browser, you will get all the products that are there without any additional features for querying. Because for our use cases in the EO dashboard, we never needed a specific API. You can see some kind of metadata on the page, which we have defined and filled that are also used in the client for follow-up filtering. So I'm looking at the OMI nitrogen dioxide data, and when I look at a single item, I see its date time. That is the most important thing for the dashboard, because usually we are not accessing the raw data. We are just accessing services which are serving the data. If it's WMS or a tile server from the VEDA platform, doesn't matter. We have adapters for all the data services that all the currently available data services that we provide. I wanted to also show assets and metadata section, which allows us to give more information about contained files that are accompanying our story or our collection. For us, that's the thumbnail and a legend currently. And we also need a few additional resources for our client, for example, to know how to query the statistical API to get the currently drawn area, as was already shown before. There is a new ongoing branch that is still not yet merged, that is showing a direct access to this catalog from our EO dashboard client. You can see it under the second link, and I also included here the credentials because it's under the basic authentication. This is for our testing branches that will get soon merged into the main. So if you want to access it as well, I do not have to fill in the password again because I already did it once. But this is a new way how the client will look like, and you can see that the metadata are used for the filtering on the left side. So we are using a different interface or enhanced filtering capabilities. And I wanted to just have a look at the nitrogen dioxide collection from the atmosphere. So this yearly data, as was shown before, in order to show that the data access looks just the same. And under that analysis, the option to generate chart is available as well. And this is again accessing the statistical endpoint of the VEDA platform. So this is accessing the production catalog. What we will now try together to do is an example of a community contributed data set. So imagine you are a data provider or a researcher that wants to have their data added into the EO dashboard. We are working exclusively with Git, so a pull request is the way to edit our configuration files. And I have prepared a demonstration scenario where we will try to add one of the data sets from JAXA, which is the sea ice concentration for the GCOM satellite. That is a data set we already have provided. This is a demonstration scenario like we were adding it. There is a link for the data provider webpage where you can, for example, get some metadata about the product that we will be adding. But we are more interested in the actual service, which will be serving as the data, and that is a WMS endpoint from Restec, which is giving us more information what we are interacting with. And this is where we will already be a little bit interactive. So I'm using the OWS library for accessing WS endpoints, just to see what layers are there and to be able to see definition of the collections that we can interact with. Some of them are already integrated in the EO dashboard, some not yet. So I have listed all the advertised layers that are under this endpoint. And I'm interested specifically in the sea ice south and sea ice north, which are, there are separated layers for the north and south. We'll be trying to add one of them. When I just want to have a look at definitions and metadata of this WMS service, I can see that there is a lot of available times. So these are daily data since 1978 and compassing the whole world. So it's data for around the globe, and there is already a set style defined. Okay, so how do we get this data into the trilateral dashboard? For that, we will access EODash catalog repository, and I will just guide you a little bit through the structure of how it can be done. There is a wiki page showing the concepts again, that there is entity of a catalog. Currently there are 3 of them. There is a collection, and then there are some other objects which are defining parts of the configurations that we need to define for each collection that we want to add. For us, it will be mainly the necessity to edit a catalog and add YAMLs for the collection. So I'm going back to the Jupyter lab where I will be conducting this scenario, and you can follow on with me. The repository is public, so you can clone it into your workspace using this other command of git clone. That will take me a few moments. And when I want to refresh okay, I don't even need to. On the left, it appeared. There is a EO-catalog repository where I can see the full content. I will first show what is in the catalogs because there is a trilateral YAML catalog. And you can see all the datasets that are currently embedded in the stack collection. Whenever we are generating our stack items internally, this is what it will parse and go through. And you can see that there is no GCOM-W CIs there, so we will need to add it under the collections. Second step, okay, there are many collections currently already defined, and each YAML here is defining a collection in our interface, and we need to now add one such collection. So I can start a new file for just this YAML, which I need to do here under the text file. It's in the correct folder, and I can rename it as CIS-GCOM-W. One thing to notice is one part of the whole workflow is somewhat taking time, and that would be not suitable for this workshop, and that is the generation of the whole catalog for all the collections, for all our catalogs. So this has already been prepared, but we will get to that concrete step after we are done with creating the YAML. So I think the easiest way how to define a new collection is to take an existing definition of other collection and see what metadata are there, needs to be filled. And I want to have a look at this net primary collection, which is an example of already filled collection accessing the data from Veda, which I can copy over, and I will be documenting and modify it as we go along, and I will be documenting what we need to add, because there are a certain set of mandatory fields that we need to adhere to. The name is the most important. That will be the name of the stack collection that gets created internally by our generator. I can see, I can just follow along my naming convention that I have in the file name. So I will have CIS-GCOM-W. And I will also add that to a title, which is displayed in the EO dashboard as the dataset name, allowing you to filter. EO-identifier is something you can completely come up with yourself. It just does not, it just cannot be something existing in the EO dashboard. For us, I will go with N12 because it's a demo scenario. This will be the identifier of our CIs collection. Description can be a string, so it can be any additional info that you want to show about your collection that you plan to add, or it can be a link to an assets repository where a markdown file with rich content, videos, images, and so on can live. For us now, I will just leave it as empty string. Themes needs to match the set of themes that we have under the EO dashboard. For us, CIs means cryosphere theme. So here we are working with a predefined set of strings. Tags allow you to additionally filter on data. For me, that would be, for example, CIs tag, but it can also be left as empty. It's not a mandatory field. And that is the same with satellite, sensor, and agency. I can, for example, say that it's going to be GCOM-W satellite and the same for sensor, but I could also leave this empty, and agency is going to be JAXA. There is a specification of a provider, which lets you give more information about who provided the data. For this, I would just use the official production distribution service of this product. so I can copy over the link to this platform and add it as a link for now. It's also not that important, and you can also define a host of your data, which will be the WMS service that we are accessing. I will just keep the description empty for now, and the name of the provider will be the JAXA API, which we have in the notebook here that we accessed. This is the OGC endpoint for the WMS. So I can go back. The citation is another element that you can fill in. I will leave it out for now because we are not working with some research product. We are really working with for the source product of the agency themselves. What is important mainly is the services and resources. So services are for any statistical APIs that we have interaction with. We currently support 2 of them, the VEDA statistics and the Sentinel Hub statistics endpoint. For JAXA, we currently do not yet support any of their analytics endpoints, so I will just keep this one out. But we want to define a resource. That is the WMS endpoint that we are going to be interfacing with, because this endpoint is internally used for getting me the list of dates so that I do not have to fill it manually into the stack definition. I will also need to set the type. That's going to be WMS. A name, I will cheat here a bit and have a look at another of the collections that is for JAXA to have it right, which is going to be the NDVI. So I'm looking at an existing definition of a JAXA endpoint, and I can see that the name is WMS and type is time, and the endpoint is actually the same because for the JAXA we are working with the same endpoint for all the collections. And we need to also define the layer ID in order to get dates for this one concrete layer. While layer ID for us is going to be CI's Nord. That was the one we were accessing for inside our notebook. Just checking CI's Nord. This is all, and we could also optionally add legend. These are all the metadata that are necessary for our collection definition. And one more step is needed. I would need to add this file name that we have created, which is same as a collection name but doesn't have to be, into our catalog so that it gets correctly added. So on any place of this collections array, I would need to add the identifier of the collection. And coming back to the wiki, we have filled the collection definition for our new collection, and we have added entries into the catalog. What would now happen internally is whenever a merge request is created to this repository from anyone, a pipeline will run underneath, and it will build the whole catalog with the new additions, and it will also deploy it. That is something that would be the next step inside our playbook. I have already prepared this pull request in order for us to have the catalog already deployed under this URL. So there is a schema how such a collection will, or where this collection will appear, and that is depending on the branch name that we save our merge request with. So I have prepared a pull request under the branch name CI's concentration, which is adding a similar YAML that we have just now created together. I have named the collections a little bit differently but you can see that the resources endpoint is looking just the same, and all the metadata are looking similarly. When we have a look at the deployed catalog via the stack browser, you can see that it goes to a different URL than what we were working with originally. I should have opened it somewhere. Here it is. Okay. So the catalog looks very much similar, but when I query sea ice concentration, trilateral catalog, sea ice concentration, yes, here we have querying under N12, which is part of the identifier name. We can see the sea ice concentration Arctic and Antarctic. I have also already embedded the legend, which I got from the WMS endpoint as a file defining the style. I can open it. It gives me all the available dates. For here, you can see that it's very many, so the whole catalog collection entity is very large. But we have time entry for each time that the WMS endpoint also supports. You can see the metadata that we have filled under the description, and you can see the legend and the thumbnail and the links to the data providers as producer and host. So this is how we defined externally available endpoint for the stack catalog for an entity that didn't have a stack before. So the WMS endpoint had just the visualization. And what we can also have a look at is how this newly added collection would look like in our EODash client if it were already deployed. So we can add via the catalog query parameter a behavior that we will not be looking at the official production stack catalog, but one that we just deployed. And for this, we again use the branch name from the EODash catalog into our URL query. So when I have a look at this trilateral testing instance, you can see again very, very similar interface, but already with indicator query and 12 observing the data. I could also change or search for the layer based on the satellite here. For us, that would be the GCOM-W. So this would limit me the set of collections. No, this is GCOM-W. And I can change between the Arctic and the Antarctic. Ideally, I should also see the WMS layer here, and I'm not sure now why it doesn't show it. It did. It does. Okay, it caught itself. So yeah, for the Arctic, we can see that there is the WMS layer that we were originally interfacing with. You can see the metadata here in this right part, and we can filter based on the left part on the metadata themselves. So this was the interactive, more or less interactive showcase. If you followed along, it would now be the option to open a merge request manually to our repository of the EODash catalog. And the catalog would take a few minutes or a single tenth of minutes to actually deploy itself, and you would be able to see it under a branch. And this is what we have planned as a future data inclusion from other parties than just the data scientists being part of the team. And I think that concludes my session for the EODash catalog.
Are there any questions from the room?
I have a question. What if I already have stack items or stack API? Can this directly be linked?
Yes, that is what we are using with the VEDA API, because they were the first to come up with the stack in production from the all services that we interact with. And we have an adapter just directly for accessing stack data. What it internally does, it copies over the references to the items. So we are making a copy, not a link. So we are duplicating data per se, but we need some more metadata on our side to be able to work with the catalog from our EODash client. But that is ongoing thing that works.
Okay, thanks.
Thank you for the question. Okay, so if there are no more questions, I would pass.
Hello everyone, let me introduce myself. I'm Yuta Tochigi from JAXA, a member of JAXA Earth Observation Dashboard Working Group, and I belong to Satellite Application and Operations Center. Today, on behalf of our team, I'm going to present the features and the functions of JAXA EO dashboard using COG, WMS, and WMTS. Here is a slide of JAXA Earth Observation satellite history. JAXA plays an important role to provide solutions to the various societal global challenges and issues through its satellites. 15 satellites has been or is being developed so far, including the collaboration with the other space agencies. For the conventional satellites data provision, JAXA operates a portal system called G-Portal. When users search for a specific product to download, they can also filter by the detailed information based on user preference. However, unfortunately, it is still difficult for non-Earth observation experts to search, order, and use data from G-Portal and the other web applications such as JustMess and GSMap. Furthermore, they have to perform the map projection and conversion in order to visualize and handle the data by themselves. Therefore, it is highly desired to engage new users in an easier way. Based on JAXA's awareness of issues mentioned in the previous slide, we have been promoting tri-agency cooperation in the development of the Earth Observing Dashboard. Since April 2020, we started to consider its collaboration to the public against the COVID-19 situation. The first version of EO dashboard has been released as a COVID-19 dashboard. In May 2022, EO dashboard broadened its scope with 7 semantic domains by utilizing the dual storytelling to effectively communicate the observed environmental changes with human activity. This is very useful for the public, from the scientists to decision makers, including the people who are not familiar with satellites. We have agreed to continue this collaboration through June 2024. In the discussion of trilateral EO dashboard collaboration, JAXA developed its own Earth API services compliant with WebMap service, WebMap tile service. And then we also started to develop its own dashboard. That service consists of 3 main components. Firstly, JAXA Earth database. It contains a lot of JAXA's EO satellites data, including global level landforms and environmental conditions, with code format file and metadata named CAD4L. Secondly, JAXA Earth API for Python. It enables users to acquire the data from the database directly and has an interface with QGIS. Finally, JAXA Earth Data Explorer. It is a web application service that directly visualizes various types of satellite data stored in the database. Through these functions, both trilateral EO dashboard and JAXA's EO dashboard are interfaced with these API services. It means worldwide users can access JAXA's database through these dashboards. Here is an example of API services. On the EO dashboard, you can identify forest and non-forest area using WMS service. Users can set the specific URL on QGIS as well. On the EO dashboard, you can also compare forest and non-forest area very easily using before and after slider. Then you can identify the transition of deforestation during 2 periods. Finally, in conclusion, we developed and released JAXA Earth API services that enables users to acquire and process a variety of JAXA's EO data on GIS web application without worrying about the detailed specification. As a way forward, we will maximize the curated datasets and stories to indicate how to utilize the satellite data in science themes, and try to enhance the front-end, back-end functions and API services, including the JavaScript API, by considering the collaborative activities with NASA and ESA. That's the end of my presentation. Thank you very much.
Okay, maybe we get started and then as they
Okay. So, thank you very much. I'm Diego. I work for the RIA group, supporting the European Space Agency on data processing, operations, and AI topics. And now we're going to continue our hands-on session with this notebook that I would like to run together with you. And I hope you are connected and you spawn your environment and you got access to this notebook, which is about fire impact analysis. And it's actually the geostorytelling using RAISE, your dashboard, as Anka already explained and guided you through. And by using the EDC EuroDataCube features and functionalities. Right now we are going to see how to access, combine, and analyze the data found on RAISE and the EU dashboard. You can also access the dashboard here on this link I put here for you. And we are going to combine two kind of data so we can actually exploit the features of these dashboards, naming the GHS, so the Global Human Settlement dataset, and the Sentinel-5P time series data in order to combine both built-up areas and carbon monoxide emission to see how the wildfire events actually impacted on the population over built-up areas. So the GHS dataset is derived from Sentinel-2 and Landsat imagery, and you can explore this indicator from this link here. And by clicking on it, you will be directed to the EO dashboard, in which you can see the actual dataset visualized. So it is the GHS built-up areas spatial raster dataset, and from here you can also download the dataset visualize the dataset documentation, and will actually you can see here that you see data spanning from the ranging from 0 to 10,000 square meters in terms of built-up areas, and from here you can browse actually all the dataset, which is a global one. So we will be using this data here, and before actually going on, let's spend some words also on the platform we are in. Since we are on EOX Hub and the EDC part of the EDC platform, here I also put you a link you can browse, and to give you some hints on its functionalities. EDC is a cloud optimized platform that allows you to access all the open missions, Sentinel, Landsat, commercial datasets like Pleiades, Planescope, and also level 3 products like Copernicus Land Monitoring Services. Allows you to analyze, compare and correlate EO data, and manage also different kind of data formats from raster to COGS and ZAR. And one powerful also feature is that you can bring and store your own data and a notebook as well for both real-time and batch processing operations. And it allows you also and gives you also access to computing resources in terms of CPU and GPUs by deploying Kubernetes workspaces. And also makes you expose your apps on the EDC marketplace that we are going to see by means of API services as well. Here an example of the architecture workflow interacting with Sentinel Hub services and with all the architecture elements interplaying on it from both for on-the-fly operations and batch processing operations. As I was mentioning, in the marketplace you will find, for example, data products, and Sentinel Hub is an example of that. So it's an archiving imagery service. I'm sure you're already familiar with that, allowing you to process your data and using API to retrieve satellite data over a specific area of interest. And here you can also access the Sentinel Hub webpage by using this link. We got platform services on EDC Marketplace, and EOX Hub is an example of that, and is the workspace we are actually using for running our example notebook. By clicking on that, you will be directed to the page explaining the functionalities of EOX Hub. So you can actually tailor your processing environment using, for example, Conda. So you can install your necessary packages and also accessing both CPU and GPU plans according to your processing requirements. So you're already familiar, as I saw from the poll, with Jupyter Notebooks and Jupyter Lab. So it gives you also access to this, and as we will be seeing in a while. And in this notebook, we will be also using the API services, in particular the statistical API from Sentinel Hub, in which you can actually compute meaningful statistics without the need to download data, specifying so the area of interest, the time period you're interested in, and what statistical measures you are interested to compute. And you can access also description of that from this link, and I invite you to browse all these resources to get more insight on that. And another example of statistical API is the GeoDB that has been actually developed to generate, analyze, and publish geospatial data, and it uses cloud-based PostGIS database, and it can be accessed via Python via Python client provided in a Jupyter Notebook. So it is also described here in more details on the link provided. So basically, this is an overview of the platform we are going to use, and let's go now into the actually content of this notebook that was prepared by Lea Sturm from the University of Trier in Germany, and it actually goes through basically 5. We are going to go through 5 steps. The first one, we are going to make a visual assessment of wildfire events by using Sentinel-2 imagery. So we are going to to make a first visual assessment of this wildfire event in order to locate exactly an area where we are going to then specify our analysis. We are going to query as a second step the statistical API on the area of interest that we identified on step 1. We then transform the output of this request in GeoJSON polygon, so that we group all the built-up areas, and we produce a binary mask identifying, in this case, or discriminating built versus non-built areas. And then with this information, we inject this to filter the Sentinel-5P data in order to then compute the corresponding carbon monoxide content on the selected AOIs. And then as a final step, we are going to display the results as a chart, displaying the carbon monoxide concentration and evaluating so the carbon monoxide emission on the built-up areas. So I hope the workflow is clear. And then, if you wish, we are going to run together the notebook cells on this environment. So in this cell, first of all, we are going to import all the necessary libraries that our notebook is going to use from NumPy, GeoPandas, Rasterio, and Sentinel Hub. And here you can click on Run so that the notebook can import these packages. Afterwards, on cell number 2, we're going to get past the Sentinel Hub credentials to our Sentinel Hub configuration. So we can run here. And then we are going to create here on the left-hand side a folder, directory for this exercise, for this session, where all the produced files will be stored. By running on that, it will be produced a folder here on the left-hand side with coded by the date. So we just produce this directory, this folder. So, as mentioned, our purpose here is to assess the impact of wildfire, and we're going to concentrate on the summer of 2022, which was for Europe quite exceptional, with a high number of observed fires and also a large extent of burn areas, and as a consequence also large quantity of atmospheric emissions that we are going to assess. In particular, we're going to focus on the Gironde region in southwestern France, near Bordeaux, as mentioned in 2022. And the actual significant event took place on July the 17th of 2022. So with this information in advance, we know in advance where to focus our analysis. Here also there are useful links which you can actually have more information about these exceptional events from the European Space Agency, Wildfire France, and also the stories and videos describing these events in also in the city mentioned, and links from the European Commission describing also the record season that actually harmed Europe with fires last year. So you can browse all these links to have more details. So as mentioned before, first of all, we are going to make a visual assessment of this event on the southwestern region of France. And so we are going to use a Sentinel-2 image. So we are going to look at the true color image on the day that we mentioned before. So we are going to define bounding box coordinates of the macro area that we identified before, and the resolution, and we are going to set up also the coordinate system. So by running this cell, with this cell, we are going to set up all these parameters, and then we're going to display the area here. By running this cell here, we displayed actually the AOI, the first AOI we are looking into. Then, as a second step, we are going to access the actual Sentinel-2 data, and we are going to compose a Sentinel Hub request for that purpose. So, a Sentinel Hub request object is composed by an eval script, as we will be seeing. The data collections with the time interval, the format of the response, and the bounding box with its sides. We're going to use 3 RGB bands, 4, 3, and 2, the Sentinel-2 L2A bands. So here on this cell, actually it implements what I described so far. By running it, we set up the eval script and the Sentinel Hub request. Now we are going to visualize the actual image. So we're going to send a request, and we use this utility, the plot image utility, to display it. It's still running. You can see it's still running from the asterisk here in the cell. So it's going to retrieve the image and sending the request to Sentinel Hub. Okay. So in the meanwhile, are you able to follow along and run in the cells so far? Okay.
Maybe it's the connection, because that may
By you, something?
no.
Are you getting something?
Yes. That's why I said maybe the connection.
See again. Okay. Very nice. Here you see the actual Sentinel-2 image, and in this way we can actually refine our focus on where actually the emissions is, about the direction. We can also assess the direction of the emission that, as we can see, goes from the top right corner of the image to extending actually westwards. So we are going then to refine our analysis and concentrate on this area. So this step allowed us to assess in the first place what is the most impacted area that we want to analyze. On this purpose, then we refine our analysis, and by running these cells, we display the actual the actual area that we want to analyze. And then its resolution and the number of pixels that this AOI actually is composed of. And now comes the second step that I was mentioning before at the beginning, in which, so having identified our AOI, that will be the focus of the event, we now have to query the GHS layer, so the Global Human Segment dataset. We can cross-check and interconnect these two information that from the AOI specified before with the built-up areas provided by this layer. So, in order to do that, we need to provide the ID, which is found on EDC and is already provided to you. The coordinates as GeoJSON as we did in the previous step, the time frame, and the user credentials. So we saw that the wildfire event took place in July 2022, and the GHS dataset is composed by information coming each 5 years. So we are going to select 2020 as the closest year to the actually event we are interested in. And here you got also the source of this dataset and more information about it, and also the link that I showed you before. And the purpose of this step now is to extract a data mask from the built-up areas, and we are going to discriminate from populated versus non-populated area. So we are going to build up a binary mask representing with 0 the value, the pixel value that corresponds to non-built-up areas, and otherwise we are going to retain its original value that spans from 0 to 10,000 square meters as of built-up areas, as we saw before. So you can of course play with this kind of logic if you are interested in having a more granular analysis, for example. And so by running this cell, we set up the eval script and the Sentinel Hub request, specifying, as I was mentioning before, the time interval as the 2020, the whole year. And we are now able to extract the population density as a GeoTIFF file, and we are just going to cut out pixels with 0 values, and as mentioned, you can play around with this threshold to make a more refined analysis. And so with this step, we are going then to create our binary mask. As you can see here in this plot. So in black, you got the non-populated areas, and in white, you got the populated areas. And from this step on, we are going to then create a GeoJSON file that will contain the populated areas that we are interested in. So we are going to convert this mask into a GeoJSON file, so that we can inject this information later to filter out Sentinel 5P data on the built-up areas we're actually focusing on. And then we can also plot the GeoJSON data on the map, as you can see here. So we are going to extract then these coordinates and using them as an input for the Sentinel 5P.
As mentioned before during the presentation, we're going to use the statistical API provided by Sentinel Hub for that, in which we can actually take advantage of non-downloading data and just extrapolating useful information that we want to analyze. As you can see here from the request composition in the data field, you got the multi-polygon that we are going to request, and the corresponding coordinates that we extracted in the steps before as the GeoJSON files, and that we are using again here in the request composition. We actually set up the time range we are interested in. So as mentioned, the event took place in July. We are setting up a time range from July until August. We will be analyzed so this time window, and the evil script with the information, and this is the extracted statistics. We are interested in the first and second order statistics here, and we are going to extract so the mean and standard deviation of this data. And as a final step, we produced the plot which represents the carbon monoxide values over the built-up area that we identified by combining both GHS data and Sentinel-5P data. And in black, you see the black spot representing the mean of the carbon monoxide values over the time frame that we specified as shown before, from July until August. You can also see the from here a confirmation of what our first exploratory analysis told us. So an increase in the carbon monoxide concentration exactly over the period of the image that we actually displayed before, with a spike around the 17th of July when the event actually started, as you can see. And the blue vertical lines also representing the standard deviation, which signals actually an anomaly in the carbon monoxide levels over this period of time. So it is a confirmation then of the higher carbon emission that actually took place in France in this region. In this link you can also understand more about this event, which was exceptional in 15 years. To understand more and learn more, you can also access the story in the EO dashboard. As Anka was mentioning, that describes actually in general the wildfire events and its impact on its environmental impact. So you can of course play around with this notebook by varying, for example, the year you want to analyze, the AOI you want to analyze. You can think of different thresholds, for example, for the human settlements that you may want to set up to make a different kind of analysis. You can also think of automatize that script, for example, that notebook, to run or to loop over a predefined set of areas that you want to monitor, or by actually automatically extracting anomalies that you may find globally caused by this kind of events, or that could be related to this kind of events. Just to give you some kind of hints on how you can expand on this exercise that we run through together. So to wrap up, we saw that by the powerful and the power of these dashboards and the backend associated to it allows you to integrate and combine different kind of information to give you on the possibility to monitor important parameters, in this case carbon monoxide levels over a region of interest. We did so by accessing the GHS dataset on the dashboard, analyzing the AOI to get a first visual assessment of the event, then specifying and refine our analysis on the AOI, and then combining the information extracted from the built-up areas of the GHS data with the information of the CO time series from Sentinel-5P to get then statistical analysis and of the carbon monoxide emissions on the region, on the time which took place. And this wraps up the notebook and the actually exercise we did together. Hope it went smoothly for all of you, and you will be able, and you were able to run all the cells correctly with the expected output. Okay, thank you very much for your attention.
There we go. Okay. So I'll be taking you through the notebook, top right, that says the VEDA API BiDS. And we'll execute, and yep. If at any point you have a question, feel free to interrupt, by the way. Oh, yep. Are we? Already. Sorry. This one, right? Or I'll do this one. Okay. So the notebook I'm taking you through consists of roughly two main parts. First, we will just try to access the VEDA catalog and do some tiling. And then in the second part, we'll try to recreate one of the stories on EO dashboard that is powered by VEDA data. So let me see. Where am I? Okay, there we go. So we're going to be, so VEDA is powered by Stack. So in this notebook, we are using the PyStack client and to access the Stack catalog. And we're also going to using the T-tiler, which is the dynamic tiler that sits in front. So we're defining those endpoints here. Here we're just instantiating. Okay, and there we go and try to connect to the Stack catalog and do something very simple, which is printing all the titles and IDs of the data sets in the catalog. So this is everything that's right now in the catalog, over 120 data sets. And then, I'm very sorry, but I don't know how to mirror, so I have to sort of. So here, what we're going to be doing next, we're going to be taking one of the data set IDs, and in this case, it's NO2 monthly. And we're going to print all the items in this collection. Here you can see an overview of all the items in this collection, and these are monthly NO2 products. So now we've listed them. Now we're going to be looking at the first item in that list, and we're going to get some statistics from it. So we're using the T-Tyler instance. There's a statistics endpoint, and we're passing this first item, NO2 monthly item, to the statistics endpoint, and what we're getting back is just some very basic, min, max, mean values, etc. B1 stands for the first band. In this case, there's only one band, but you would get multiple, or you would get statistics object per band back. And we can use this. We can display this cog in a map as well. So what we're doing here is we're setting rescale values. So using the min and max values that we found in this item, we're setting sort of the min and max of the color scale, right? Which right now we make the request to T-Tyler, and we're passing we're passing the item ID, etc. We're passing the color map, and then we're passing the rescale, so these min and max values, and the result is a tile JSON, which we can then pass to Folium to actually show on a map. And this is that NO2 monthly product that we just got from Stack. It looks very blue, but if you zoom into certain places, you can see here, for example, I think this is mainland China. You see very high emissions. And I think there's a place here. I'm not certain this looks like the... Yeah, the peninsula. I don't know exactly where it is. Does somebody know exactly what place that is? No? Okay, it's somewhere. Very blue map. So not very useful, right? Because we're using the min and max values of that are found in the data. Obviously, there are places with very, very high values that sort of skew the distribution. Is just a little bit off, but because we're using T-Tyler, dynamic Tyler, it's very easy to make this map slightly more useful and show a little bit more variation elsewhere. And what we're going to do now is just very quick and dirty. Basically, what I'm doing here is that same rescale that we just said, and we were just using min and max. Now I'm just quick and dirty dividing the max in half, right? There are other ways to do this. T-Tyler comes with a lot of different options. You can adjust gamma values, right, where you sort of adjust the midpoint of your color ramp. But here we can also just adjust the thing in half, and then we're doing exactly the same. So we're asking for the same. We're making the same request, except for with a different rescale value. And then when we show the map, we see a little bit more variation already, right? So obviously, I mean, here everything, surpasses the max, but here you already start to see a little bit more variation. For example, I think this is Northern Europe. I don't know.
Netherlands, Belgium.
Germany, maybe, right? right? And this is the power of dynamic tiling, and this is also something, for example, on the Veda dashboard we're using quite a bit, right? Allowing users to adjust styling, right, or adjust min-max values or these kind of things. Cool. Any questions so far? This is the first part where we just looked a little bit at accessing stack and throwing some data at the tiler. If no questions, then I'll go to the next part, which is we're going to be looking at one of the stories on EO dashboard. In this case, it's air pollution, so nitrogen and sulfur dioxide, and which is looking at the US, China, and India. And we're going to be recreating these graphs somewhat. Cool. So the data products that we're going to be using, we're just setting the IDs here. And then the other thing we're doing, we're sort of setting very rough AOIs. These do not 100% line up, but they're, you know, they roughly line up with the AOIs that we used for the story as well. So here we're you know, defining a function that passes the AOI, and yep, we're basically the same sort of what we did before using the statistics endpoint of T-Tiler. Let me see, let's just walk through just to make sure we're not skipping anything. Well, and then, yeah, exactly, I was afraid of that. 1 second, let me just define the collection. Cool. It's still running, right? I can't really see. Here we're, by the way, searching for both the NO2, so we're passing two collections. Or we're requesting two different collections, and then you know, generate these stats. Oh, yeah, it's done. Cool. And then once we have the stats, we're going to create a pandas data frame. Here we're doing some basic housekeeping, you know, getting the year from the getting the year from the start date time, and then here basically what we're doing, we're calculating a change of mean values in relation to a baseline year. Clean stats, and then we are creating a plot using that data. So this uses the NO2, SO2 data in the Veda data set against T-Tiler to generate these graphs on the fly. And now we can do the same for both India and I can pull up the story, oh no, wait, pull up the story up there in the meantime. that this is generating. So what we're hoping to see is roughly this. And I say roughly again because we're using slightly different AOIs, slightly more simplified ones. And there we go. I'll run China as well, so we can have that one. So yeah, here it is. Here's the India one, which, you know, roughly shows the same pattern, and the same goes for now for China. Almost there. Oh, no, China was before. There it is. So we're roughly looking for this. Oh, there you go. Yep. Follows roughly the same patterns. And that's it. That's the notebook. That's all I had for the notebook. I think it's time for the QGIS tutorial, Corey, right? Cool.
I have a
Yeah, sorry, yeah, go ahead.
I think in some previous presentation we saw a possibility to, in the EO dashboard, to draw a polygon and click
Yep.
generate chart. Is this also possible with these kind of specific functions, so that we have the dashboard for the three predefined areas? But what if the user wants to have its own AOI without using the notebook?
So whether you can send your own AOI to it? Is that the question? Is that the question? Yes.
Especially when you build your own custom dashboard.
Yep.
For example.
So
To pass a function.
yeah. So I think Lubo, you're when for Veda data you're using the.
You're using in the dashboard the same endpoints, same functions as Olaf is showing. On the dashboard itself, it allows us to draw a simple polygon and a rectangle which gets converted to a polygon. And we don't have a functionality there to for example, upload your own file, which would be a nice addition. We don't have it there yet. But that can get saved into the custom dashboard as well. The chart that got generated, so not the map that was used to draw it, but at least I think it's possible.
Yeah.
So I think you can kind of trick it if it's just a simple polygon, because the coordinates are in the URL, so you could probably just, if you want to specify something, but it's not like super easy, yeah? I mean, it's easy, but you have to kind of
Yeah.
trick it a bit.
But I think this is mostly a T-tiler itself accepts very complex polygons. Of course, it will take a lot more time to generate the areas, but T-tiler itself is you can pass it any sort of custom geometry, a GeoJSON, right? And then it's up to sort of the applications that sit on top of that. I don't know how, however complex you want to make it for the user, you can make it as complex as you want. Simple versus
No, I mean from the front end you cannot do it. From the client side you cannot do that.
No, exactly, right. And maybe you don't want. And maybe you don't want to, right? Because I think some of the dashboard, some of the people that use a dashboard might not even know, right? They can draw they can draw an AOI, right? They don't need to know anything about GeoJSON, and maybe you want to make it very easy, right, for them.
I think that would be a good example to show the data provider does not need to be the user that defines the Python function to generate the chart. but the ones who created the dashboard chose in your example 3 areas, and then the user could also use an own
Yeah.
area of interest, but just a bounding box.
Yeah,
Keep
yeah,
it
yeah.
simple.
Yep. Yep. Cool. Thank you.
Great. Thank you a lot.
Thank you.
Hello everyone, my name is Kaori Kuroiwa, Remote Sensing Technology Center of Japan, district. My presentation is QGIS using EO dashboard data from JAXA's WebMap service and WebMap style service. So I would like to lecture how to access and view the JAXA's WMS, WMTS using QGIS based on the agriculture use case. Here is my presentation outline. First, I would like to explain the introduction about the satellite data applications for environmental impacts. Next, I'd like to introduce the case study 1 and 2. So case study 1 is the drought of US Southern Plain region this year. And then case study 2, global monitoring biomass using the forest, non-forest map. Finally, JAXA's EO dashboard service will be provided. First, satellite data application. This slide is advanced in satellite monitoring, taking a crop monitor as a good example. So providing insight into agricultural production, crop conditions, and food supply are among some of the most impactful information afforded by Earth observation satellites. Information derived from the data retrieved can affect the price we pay at grocery stores, policy implementation from regional to global scales, and food security around the world. Satellite monitoring can provide products open timely, science-driven information on crop conditions in support of market transparency. The Geogram Crop Monitor Initiative are supported by the Global Agriculture Community and the National Space Agencies, including the NASA Harvest Consortium and US-based institutions, JAXA and JASMINE, ESA and several European institutions, Ministry of Agriculture across the globe, and many more. So this is a screenshot example of a screenshot of stories of agriculture on EO dashboard. Here is you can see here geogram crop monitors results of June this year. So we will see the watch area, yellow color, and the poor area, orange color. It's in the United States. So this is a geogram crop monitor result with crop symbol. Crop symbol is here. The end of June for wheat in the northern hemisphere. Winter wheat is harvesting it as spring wheat develop under mixed conditions. Mild conditions are mixed and dry conditions spread across the US. Mexico, northern China, and central Ukraine. Soybean harvesting lab up in Argentina, as dry developed in the US, Mexico, and northern China. So we can see icon of wheat, and maize and soybean here. In the United States, poor and worse conditions area. So we are going to investigate these areas with QGIS later. So let's start the case study 1. Here we are going to check the distribution variance of soil moisture anomaly, precipitation anomaly, and the normalized difference vegetation index anomaly for the case of drought of United States. So in the geogram crop monitor July report, in the US, harvesting of winter wheat is underway with poor conditions in the central and the southern Great Plains due to prolonged drought. So you can see the less NDVI. Here is an NDVI. NDVI, there is a less NDVI compared to 5 mean years. Blue is shown this year, and brown is shown the 5 mean years. The same tendency is shown precipitation amount and the soil moisture. So you can, as an example, this figure shows the soil moisture anomaly in this June. So red area is shown dry area. So we are going to investigate these phenomena precisely by using the QGIS. So this is a basic diagram of QGIS operations to use JAXA's WMS, WMTS. First start QGIS and added the WMS, WMTS layers, and then choose the data set as layers, and then add the temporal controller. So because we want to check the temporal tendency, so we add the temporal controller. And then set the transparency. It's this optional step, but with this it becomes easier to confirm where we can look, we are looking using OpenStreetMap. After these preparation steps, you can view data and compare time dimensional variation of multiple physical quantities. So let's start the QGIS. So first, you choose layer and add layer, and then here add WMS, WMTS layers. So you create a new connection and input the arbitrary name you like. And then input the URL to connect the WMS of JAXA. The URL is here. So I think you are already have these materials. And then click the OK button. So you select the, create the layer name and connect to this. You can find the data, candidate data list from here. Here, so you can choose the 3 data sets. One is the soil SMC anomaly GCOM-W World Monthly, the soil moisture content. And NDVI anomaly GCOM World Monthly data. And PRC precipitation anomaly GS map world monthly data. So add to the layered panel. So these layer name is simply they are divided from JAXA satellite, GCOM-C and GCOM-W observation data. So GS map use multiple data and ancillary data as input, including GPM, GCOM-W, DMSB, NOAA, and METOP satellite. So, and then optional step, you can set a transparency from these properties. In this case, 50%. So 3 layer is set at 50%. And then add the OpenStreetMap. So you can add the OpenStreetMap, XY tiles, and OpenStreetMap. Drop and drag here. So you can change the order. OpenStreetMap is the baseline. So, and also you can check this checkbox, show off and show on. So zoom into the United States. And we can also add the temporal controller here. So this data is monthly data. So you can see the temporal tendencies, this data from mid of January to June. So like this. So this is the precipitation anomaly. The blue mean is less than the average years. So next month, like this. So you can see the blue area. Blue area means less the precipitation than average years. So you can also check the soil moisture content like this. Same operation. So blue area means same mean soil moisture content is less than the average years. So last thing is an NDV anomaly. So you can see the time series images like this. So all the data is it tends to lower than average years. So you can compare the time dimensional variation of merged physical quantities like these. So let's move on to the next case. So next case study is global monitoring biomass forest non-forest map. So first, I would like to introduce this data. So the global FNF maps are based on the pulsar 2 and the pulsar images to show the worldwide forest distribution from year to year. The map has a 25-meter resolution and available in 2007 to 2010 in internal maps by EROS Pulsar and 2015 to 2021 by EROS 2 Pulsar 2 data. Such internal forest distribution map provide essential information for forest monitoring activities, including climate change countermeasures. So if you want to know that in more detail, so access to the EO dashboard. So you can select the Explorer dataset, search the forest non-forest map. So you can see the changing the forest areas compare with the 2 years. For example, so we will zoom to the Borneo Island. Here is a Borneo Island. So this area, this island is reduced the forest area. So you can see the forest changing. So so this image shows us 2017. It's changing to 2002. So you can see the reducing the forest area compare with these 2 maps. So like this. So go back to my presentation. Finally, current specifications of JAXA's WMS and WMTS. So this is a list of WMS layers of JAXA's EO dashboard. Layer name is here, and the start date and end date, and short description here. I already introduced the NDV anomaly, SMC anomaly, and the PRC anomaly. So we have provided another data, so you can access to the our WMS, WMTS using QGIS. And also, we have provided the WMS, WTS layer for forest, non-forest maps. Here is a URL for accessing the QGIS. Yes. Okay, that's all.
Thank you.
Okay. Any questions?